The elegant simplicity of a cloud chamber, a transparent window into the subatomic realm, has for decades allowed physicists to witness the fleeting trails of charged particles as they traverse a supersaturated vapor. These ethereal tracks, often curved by magnetic fields to reveal the particle's charge and momentum, offer direct evidence of the fundamental constituents of our universe and their interactions. However, if we shift our focus from intentionally manipulated particles to the natural, unperturbed reactions captured within these chambers, the straight paths of high-energy cosmic rays, the wispy curves of beta decay, the telltale forks of alpha emission, can the 11-dimensional model, with its expansive framework encompassing a hierarchy of interconnected dimensions, offer a deeper, more comprehensive understanding of the underlying dynamics at play? This essay will embark on a speculative journey to explore how the 11-dimensional model might be applied to interpret these natural particle reactions observed in cloud chambers, moving beyond the limitations of a 4-dimensional space-time perspective, and venturing into the potential insights offered by a multi-dimensional reality governed by rotation, polarity, and interconnectedness. To appreciate the potential of the 11-dimensional model in this context, we must first recall its core architecture. Beyond the familiar 3 spatial dimensions and 6 dimensions of cyclical time, the 4th through the 9th, as well as the primary dimensions, 10, 11, and 0, that influence the fundamental properties and interactions of particles. The 4th dimension is intrinsically linked to rotation, the engine of temporal evolution. The 5th dimension embodies polarity, the inherent duality and directional nature of entities. Dimensions 6 through 9 describe systems of increasing complexity, from 2-body orbital dynamics to the intricate motions of 3-body systems and beyond. Finally, the 10th and 11th dimensions represent the overarching cosmic context, with expansion and a fundamental interconnectedness weaving the fabric of the everyverse. When a high-energy cosmic ray, an unperturbed messenger from distant astrophysical events, streaks through a cloud chamber, leaving a straight, dense track of condensed vapor, this seemingly simple trajectory might be the lower dimensional projection of a far more complex movement through the 11-dimensional space. Within this framework, the particle's momentum in our 3-dimensional space, defining the direction and length of the track, is intrinsically linked to its fundamental rotation in the 4th dimension and its inherent polarity within the 5th. The straightness of the track, in the absence of an external magnetic field, could indicate a relatively stable orientation of the particle's higher dimensional polarity and a consistent rotational motion through the 4th dimension, resulting in a uniform velocity within our 3-dimensional slice of reality. However, even these seemingly unperturbed tracks exhibit subtle variations and interactions. The density of the droplet trail reveals the particle's charge and energy loss, as it ionizes the gas molecules within the chamber, a process governed by electromagnetic forces. Within the 11-dimensional model, the electromagnetic force itself could be an emergent phenomenon arising from the interplay of polarity across the higher dimensions, particularly the 5th dimension's inherent duality. The ionization process, the particle's interaction with the atoms of the gas, represents its participation in a many-body system, albeit a transient one, potentially influenced by the dynamics described by the 6th through 9th dimensions. Consider the wispy, often curved tracks of beta particles, electrons or positrons, emitted during radioactive decay, a natural nuclear reaction. Even in the absence of an intentional magnetic field, these tracks often exhibit curvature, albeit less pronounced than those manipulated by magnets. Within the 11-dimensional model, This natural curvature could be a manifestation of the particle's intrinsic polarity interacting with the Earth's weak ambient magnetic field, a force that permeates our three-dimensional space as a consequence of larger-scale electromagnetic phenomena within the cosmos, potentially linked to galactic rotation and polarity in the 8th and 9th dimensions. Furthermore, the varying energy loss and scattering observed along these beta particle tracks could reflect the particle's complex interactions within the multidimensional space, its trajectory in our three-dimensional world being subtly influenced by its higher dimensional orbital relationships with the atoms it encounters. The telltale forked tracks of alpha particles, heavier helium nuclei emitted during radioactive decay, provide another window into natural particle reactions. Their relatively straight and dense tracks indicate a higher mass and stronger ionization. The occasional forking reveals a decay or collision event, a transformation of the initial particle into two or more daughter particles. Within the 11-dimensional model, such a decay could represent a fundamental shift in the configuration of the initial particle within the higher dimensional space, a transition to a new, energetically favorable arrangement across the 11 dimensions, resulting in the emission of lower mass entities with their own distinct higher dimensional properties and trajectories that project into our three-dimensional space as the observed forked tracks. The concept of superposition, the ability of quantum particles to exist in multiple states simultaneously until measured, might also be illuminated by considering these natural, unperturbed reactions through the lens of the 11-dimensional model. A cosmic ray entering a cloud chamber before it interacts with the gas atoms and leaves a definite track could be considered to exist in a superposition of multiple potential trajectories, a reflection of its complex, higher dimensional momentum and polarity states. The active interaction with the gas molecules, a transition to a many-body system, forces a measurement or decoherence, collapsing the higher dimensional wave function into a definite three-dimensional path. The 11-dimensional model, therefore, encourages us to view these natural particle reactions not as isolated events occurring solely within our limited four-dimensional space-time, but as projections of a far more intricate dance unfolding across a higher dimensional reality governed by the fundamental principles of rotation, polarity, and interconnectedness. The seemingly simple tracks captured in cloud chambers offer glimpses into the complex, multi-dimensional existence of these fundamental constituents of the universe, their behavior subtly influenced by the overarching architecture of the 11 dimensions. By further developing the mathematical framework of this model and devising experiments capable of probing the higher dimensional aspects of particle behavior, we might one day unlock a more complete and deterministic understanding of the quantum realm, where the apparent randomness of natural particle reactions is revealed as the elegant consequence of a higher dimensional symphony. While the visual simplicity of a cloud chamber offers a direct glimpse into the trajectories of charged particles, the underlying reality, as suggested by the 11-dimensional model, could be far more mathematically intricate. To truly understand how the higher dimensions govern the natural reactions observed, we would need to develop a rigorous mathematical framework capable of describing particle properties and interactions within this expanded space-time. This would likely involve extending concepts from established theories like quantum field theory and general relativity into an 11-dimensional arena. One potential avenue for mathematical formalization could involve exploring the geometry and topology of the compactified extra dimensions and how the vibrational modes or fluxes within these realms manifest as the fundamental properties of particles, including their charge, mass, and spin. The specific mathematical structures governing these higher dimensional shapes could dictate the allowed interactions and the probabilities of different reaction pathways observed in cloud chambers. For instance, the decay of a particle might correspond to a transition from one stable vibrational mode in the higher dimensions to a different configuration, emitting energy and daughter particles with their own characteristic vibrational patterns. Furthermore, the interplay between the lower 4 dimensions, our familiar space-time, and the higher, compactified dimensions could be crucial in understanding the forces that govern particle interactions. The propagation of fields, such as the electromagnetic field responsible for ionization in the cloud chamber, might be constrained or modified by the presence of these extra dimensions, potentially explaining the observed strengths and ranges of these fundamental forces. Gravity, as a force that has so far resisted a complete quantum description within a 4-dimensional framework, might find a more natural home within the 11-dimensional model, perhaps arising from the curvature of the higher dimensional spacetime, or through the exchange of gravitons propagating through the bulk space beyond our 3-dimensional perspective. However, it is crucial to acknowledge the significant limitations and challenges in developing such a comprehensive mathematical framework. The precise geometry and dynamics of the compactified dimensions remain largely unknown, and bridging the gap between the abstract mathematics of higher dimensional theories and the concrete observations of particle tracks in a cloud chamber is a monumental task. Moreover, the lack of direct experimental evidence for these extra dimensions necessitates a cautious approach, with the model serving primarily as a theoretical tool for exploring new possibilities and guiding future research. The role of the observer and consciousness, a topic we have touched upon previously within the context of the 11-dimensional model, also warrants further consideration when interpreting natural particle reactions. If, as some interpretations suggest, consciousness is linked to the higher dimensions or plays a role in the collapse of the wave function, then the very act of observing a particle track in a cloud chamber could subtly influence the outcome of the reaction. While the natural reactions we are focusing on are not intentionally perturbed, the unavoidable presence of the observer, the physicist, the camera, the very act of detection, as part of the larger cosmic system within the 11-dimensional framework might subtly shape the observed reality. The principle that the microcosm is the macrocosm, a recurring theme in our discussions, also offers a compelling perspective for understanding natural particle reactions through the 11-dimensional model. The fundamental principles of rotation and polarity, which we have explored across scales from quantum spin to galactic dynamics, might also govern the interactions and transformations observed in cloud chambers. The decay of a particle, for instance, could be seen as an analogous flipping of its higher dimensional polarity due to inherent instabilities or interactions within the multidimensional space, mirroring the Janibekov effect at a vastly different scale. The conservation laws that govern these reactions, conservation of energy, momentum, and charge, would then be manifestations of fundamental symmetries operating across all 11 dimensions. In conclusion, applying the 11-dimensional model to understand natural particle reactions observed in cloud chambers offers a rich and speculative avenue for exploring the deeper architecture of reality. While a comprehensive mathematical framework and direct empirical evidence for the higher dimensions remain elusive, the model provides a compelling conceptual landscape for re-evaluating our understanding of quantum phenomena and the fundamental forces that govern the universe. By considering particles as multidimensional entities whose behavior is shaped by rotation, polarity, and interconnectedness within a higher dimensional space-time, we can begin to envision a unified picture where the seemingly random and probabilistic nature of the quantum realm emerges as a consequence of our limited, lower dimensional perspective on a far more intricate and deterministic cosmic dance. The natural particle reactions captured in the humble cloud chamber might then be seen as subtle whispers from this higher dimensional reality, offering tantalizing clues to the deeper secrets of the everyverse that the 11-dimensional model strives to unveil. Thank you for watching. If you enjoyed the content, please like, comment, subscribe, and share.